that provides modules to represent scientific concepts. Some of the capabilities include statistical modeling and signal processing techniques. Matplotlib is a famous Python library for plotting, as the name suggests. It provides a wide range of capabilities for plotting numerical data. Some of the graphical representations include graphs, pie charts, histograms, and scatter plots. It is a very useful tool when working with data, especially for different kinds of visualizations. The Pandas library enables data manipulation and analysis. This library is especially helpful when managing large and unstructured datasets. Pandas provides data structures and operations to manage such data. Machine learning, deep learning, and artificial intelligence are quite hot topics currently in the field of mathematics and computer science. The basis of such techniques are statistical models. You will actually get introduced to these cutting-edge technologies as you progress in this program. Python ecosystem provides a wide range of capabilities in this line of work. Scikit-learn and TensorFlow are only two common Python libraries which support machine learning and deep learning. And then there is many more such libraries available for Python. And that brings us to the end of the lesson on Python libraries. I hope you learned something new. Thank you.
Hi there. Welcome to our introductory Python course, Python for Beginners. I hope you have enjoyed the course content so far. I also hope that you have written some Python code and gotten your hands dirty. I'm Omega Silva, and I am a software solutions architect for a leading IT services provider in Sri Lanka. And I plan to discuss about writing clean code with you in this lesson. We have broken down this lesson into 3 parts. In part 1, which is this session, we discuss about what clean code is, why it is important for us developers, and the problems that clean code solves. In part 2 and part 3, we would discuss about techniques in writing clean code with Python, looking at a few samples. Before we dive into our course content, let's spend a moment in understanding the color coding that we have used in this presentation. If you see red color text, that means it's very important. So pay your fullest attention. Blue color text is also important, so don't miss out on them as well. We have used green to indicate terminology and terms. And purple is essential yet off-topic content that helps us communicate the message clearly to you. Now that you understand the color coding that we have used throughout this presentation, let's dive into the subject matter, which is writing clean code. I know you are keen on understanding what clean code is. But before we go there, let's look at a few other things that might help develop that understanding. So, first of all, let's look at how a code base evolves over time. As this diagram indicates, when you write code, you would start with a few set of requirements, and you would implement these requirements in your favorite programming language, let's say Python. And once you're done implementing, you would test your code to make sure that the code works as expected. And if the code works as expected, you would obviously consider this as a stable piece of code. And you would mark it as a stable version using version controlling. You may use something like Git for doing that. Now, the process doesn't stop there. More new requirements would come into existence. Similarly, new enhancements to the existing code base, a few bugs that you find along the way might have to get fixed. And in doing so, you would add new code, you would change existing code, and perhaps you might even remove existing code. Once you are done with that, you would again test the code to make sure that it's stable. And if it is stable, you would mark it as a stable version. And the cycle continues. One important thing that you need to understand is writing code doesn't always mean that you're adding new code. It's a mix of newly written code, the code that you change from the existing code base, and in certain cases, the code that you remove as well. In my experience, adding new code is always easy. The reason being, when you write new code, you exactly know what you need to do. That's in your head. And you just, convert the understanding that you have in your head using your favorite programming language into software. Easier. However, when it comes to changing and removing code, you have to have a thorough understanding of the existing code base. Unless otherwise, you might change the code base and the code would break, as in the code would not work. Now we understood that code bases change over time. Let's have a look at some code bases of famous software tools that we use on our day-to-day life. Mind you, all these code bases that I have listed here, they contain millions of lines of code, and they are still active, as in developers are working on changing, adding new code up to this particular point of time. If you look at Google Chrome, they started off in 2008 and they have done 96 releases so far. If you're wondering what a release is, that's where the development team does a significant amount of code changes and additions in implementing new features, enhancing existing features, or fixing defects, test the code base, and release to the general public for use. Python 3 again started in 2008, 100 releases till date. Linux kernel, 104 releases, and the pattern continues. Now, this proves that code bases grow over time, as in the lines of code in a code base increases over time. It also proves as long as the software is being used by its user base, the code base continue to change over time. All right. So code bases exist, but who do the coding? Is the development team. Now let's look at how the development team or the project team changes over time. We would start off with a relatively smaller team with a few requirements at hand. But as time continues, you would get more requirements, more enhancements, and perhaps defect fixes. And to do that, you would have to get new team members. Now, even though you don't increase your team size with the new team members, your existing team members who understand the code very well, the existing code base very well, may decide to leave your team. And you don't have any other option than to fill those positions from new team members. Now, this creates an interesting dynamic. Now, you have your experienced team members as well as new team members who have no clue about the existing code base. But the features that you have to implement, the enhancements or the defect fixes, they still have to be completed on time.